So our goal, first off, let me make sure my mic is working, looks like it, is to find the slope of x squared. Now, in the homework, or in the class, I guess, we already found out that the slope function for x squared is 2x, right? That tells me the slope. So at x equals 3, the slope should be 6, because that's 2 times 3. And at negative 4, it should be negative 8, because that's 2 times negative 4. But just to show you how to do this, remember, on x squared, what we're really doing, so there's 0, 0, is we're taking the point we want. So the point up here is 3, 9. Okay, that's on x squared, right? Plug in 3, you get back a 9. We want to know the slope there. So what I'm really doing is I'm creating a variable point, like x squared, or a squared, whatever letter you want to use. Now remember, that point could be anywhere. I'm drawing it right there, but it just represents any point. It could be up here, it could be here, it could be over here. Doesn't matter. Okay, so I'm calling it x squared. That represents any other point on this curve. So what we're going to do is find the slope between 3, 9 and x comma x squared. So first we're going to do y2 minus y1 over x2 minus x1. Now, I want to know what happens as I bring that point infinitely close to my other point. So hopefully you're going to see, like, so we'll look at the notation here, but we know that top factors, this is something we've been looking at for a couple days now. We know that's going to factor and cancel. So we know that thing reduces all the way down to just x plus 3. Okay, that means, again, this thing here and this thing here are exactly the same, except for at the spot we canceled, which was at 3, which happens to be the spot where we care about. So what we do for this is we put this little notation out front is what we're really looking at. What that means is I want to know what happens to my slope between 3, 9 and any other point as I bring my other point super close to 3. Okay, so I'm really bringing this point right here close to 3 like that. And I'm seeing what the slopes look like. Okay, but essentially what this tells me is the slope between 3, 9 and any other point is just x plus 3. Okay, but again, the calculus notation is to have this out here. So we're still talking about the limit. We're saying, hey, what happens to this as we bring 3 super duper close, or x super duper close to 3? And we get that. So, and you'll notice, look, if you try to plug 3 into the first version of this, you're going to get 0 divided by 0. Because the slope from one point to the same point is undefined. It doesn't make any sense. And then the same thing happens over here before we cancel out the x minus 3, so we get 0 over 0. But once we cross out those x minus 3s, we're not going to get 0 over 0 anymore. The problem was the x minus 3s. So now we get this. So I want to know what happens to this thing as we bring x really close to 3. What does it approach? And you can imagine if I plugged in like 2.99999, I would get 5.99999, which is super close to 6. And the closer I move x to 3, the closer this thing gets to 6. And that's what we say the slope is. And we knew that anyway because it was 2 times x is our slope, 4x squared. All right. At x equals negative 4, we do the same thing. Except now instead of having our point here, we're going to have our point over here at negative 4 comma 16. Okay, let's say it's this point right here. But we want to find the slope between that and any other point on the curve, which is x comma x squared. So we do x squared minus 16 over x minus negative 4. Yeah, big guy. No, 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 no. Dude, stop playing around with the door. Wash your hands and get back to work. Oh my goodness gracious. What'd I say? Go. Okay. Always an adventure having children while you're doing calculus. Anyway, that's the slope between the 2 points we care about. And as x is approaching negative 4, we want to know what's going on. Again, if you try to plug in negative 4 right now, you're going to get 0 over 0. And that means that x plus 4 has to cancel. We know the top factors like this. We're still approaching negative 4. And when you cancel out those x plus 4s, you got that going on. So we find that we get negative 8. And that's the slope of x squared at negative 4. So that's what we set up. All right. So I'm going to speed this up a little. What? Snag that right there and just come over here so I got some room to work. Okay, so we'll do these. So we want the slope of 1 over x at 5. So the point at 5 is 5 comma 1/5, and the variable point we will be using is x comma 1 over x. So the slope between those is 1 over x minus 1 over 5 over x minus 5, and that represents the slope from 5 1/5, because 1 over x looks like this over here, and like this over here. So 5 1/5 would be like right here. That represents a slope from that to any other point, x comma 1 over x. Cool. And what we're really doing is finding, again, the slope of this line here that's like connecting these dots. Okay, but we're bringing that second dot closer and closer and closer to 5, and that's going to give me the slope where I want it, just at 5. So we're going to drop out front of that the limit as x approaches 5. Now, this is a complex fraction, which we don't want, so we're going to get rid of those fractions by multiplying by the denominator, right? That's going to get rid of them, and that's going to give us the limit as x goes to 5. When you multiply this to here, the x's cancel, so we have 5 minus, multiply to here, the 5's cancel, x over x minus 5 times 5x. And what we said in class 2, if you remember, that 5 minus x over the x minus 5, they don't cancel outright, but they are going to cancel each other. They leave a negative there. So this becomes the limit as x approaches 5 of negative 1 over 5x. And if you drop 5 into that, so you're seeing what's happened as we approach 5, you're going to find out that it's negative 1/25. Okay. Yes, Elliot?
Did you flex the time?
I'll start it again. You keep working. Okay. The limit as we approach negative 3, because now we're doing this one. So the point at negative 3 is going to be negative 3 comma negative 1/3. So we're going to do the y value minus the y value, which is negative 1/3. So that becomes plus 3, right? Over the x value minus the x value. So x minus negative 3 is really x plus 3. And again, we'll do the same exact math, except now we're multiplying by 3x, because those are the denominators we want to get rid of. And that's going to leave me with, if you distribute this, it's going to cancel, right? X cancels first, so you get 3 plus x over x plus 3 times 3x. And you can see those 3 plus x's are going to cancel out, right? Leaving a 1 on top. So it's 1 over 3x, and we're approaching negative 3. So at this point, once we cross out the problem, like the 3 plus x in this case, or the x plus 3, you can just plug in what you want to know, because that's going to tell you where is it approaching. So this becomes negative 1/9. All right, let's go back over to here. Now we want to do number 3. So again, we got to know what point we're talking about as we do these. So let's zoom in on that. So at 2, the point is 2 comma, if you put a 2 into here, you get 4 times 3, that's 12, plus 2 times 2 is 4, minus 4, and that's going to be a 12. Okay, so that right there is my actual point I want to know the slope at. And I'm going to create a variable point, which is just going to be an x value, which we don't know because it's moving around, and the y value, which will just be, this is what you get when you plug x in, right? So we do the first y value minus the second y2 minus y1 over x2 minus x1. And we want to know, so that's the slope between 2, 12 and any other point on my parabola right there. We want to know, hey, what happens to that as we approach 2? What happens as we move closer and closer and closer to 2? We're bringing our points together. So here's what I know. I know that if I try to plug 2 into here, I'm going to get 0 over 0. Okay? Now that means x minus 2 has to factor out. So this is going to be a minus 16. Okay, so you put a 2 in there, right? You get 0 over 0. So that means I know automatically the top has to factor out an x minus 2. So that means the other factor has to be a 3x, because we need to get to 3x squared, and plus 8, because we have to get to minus 16 here, right? You could factor like normal if you want, but you just think about what has to factor out, it's going to work for us. So that's that. You can multiply that out, you're going to see that works out. Okay, but the x minus 2's cancel, which means that our slope function, which was this thing here really, like our slope equation, boils all the way down to 3x plus 8. And if you let x get really close to 2, this is going to get really close to 6 plus 8, which is 14. And the second one, if we plug in -5, our point will be -5, comma, you plug in 5, you're going to get 75, minus 10 minus 4. So what's that, 61? 61. So now we're looking at what happens to my slope function here, my slope formula, which is going to be, again, y2 minus y1 over, okay, Google, start timer.
What?
Sure. You have
Okay,
1 minute,
over
15 seconds remaining. Resuming now.
that. We want to know what happens is I bring my variable point super close to this. Yes, Elliot.
You restarted the timer.
Dude, I didn't restart it. It was paused. Keep working. Okay. Ay, ay, ay. As we approach -5, we're going to get 3x squared plus 2x minus 65 is over here, over x plus 5. I'm telling you, if you put a -5 into there, it's going to cancel all the way out to 0 over 0, which means x plus 5 has to factor out. So as we approach -5, I know there's an x plus 5 here. You can think about that as you factor. That means this has to be 3x minus 13. Okay, that's how that factors. All right, good job, buddy. You got to do your Alexia and you got to do reading. Okay?
I don't have to do reading. I mean Lexia.
There we go. Why not?
Because I'm all I've done 5 times 15.
We're still going to do it again today anyway, okay? It's all every day. Even if we have a little extra. -28.
Did I do 30
Okay.
minutes of Lexia one day?
Dude, I don't know. Go do Lexia, please. All right. So that's that. Number 4, I'm making young children happy over here with reading and writing homework. Okay. Wow. There we go. With the slope of this cubic equation at 1. So again, we need to know what point are we dealing with. 1, comma, plug in a 1, you get 2, minus 4, plus 3, minus 2. So what's that, -1? Sounds about right. Cool. And our variable point is going to be x, comma, 2x cubed minus 4x squared plus 3x minus 2. So our slope between the point we care about and any other point on this curve will look like, will look like this. That's the first y value minus -1, so plus 1 over, get this junk out of here, x minus 1. And we want to know again what happens when we bring our points super duper close together, because we know what the slope is approaching. So what we're going to get up top is, so I'm just going to erase this and fix it, but -2 plus 1 is really just a -1, right? If you try to plug in 1, you're going to get 0 over 0, which means x minus 1 has to factor out of the cubic. So to do that, we need synthetic division. So I put the 1 in the box, because I know that has to factor out. The x minus 1 has to factor out. So we bring down the 2 times 1 is 2, -2 times 1 is -2. Add those up, 1 times 1 is 1. Add those up, 0. So what that means is the numerator of this super cool cubic function is going to factor into an x minus 1. That's what this tells me right here. That's what I just factored out. Times 2x squared minus 2x plus 1. That's what all this junk tells me right here. Over x minus 1. And you can see, like magic, the x minus 1s are going to cancel. And now when I put a 1 in there, I get 2 minus 2 plus 1, which is 1. So the slope of that function at x equals 1 happens to be 1, coincidentally. Okay. And then we got to do for -3 also. Okay. So for -3, where we at? Oh, it's over here. So at -3, let's just change that. So at x equals -3, let me get rid of some of this junk. If you plug in -3, you're going to get -54 right here, right? That's -27 times 2, minus -3 squared is 9 times 4 is 36. -3 times 3 is -9 minus 2. Get out of here, you. So we got to put this all together. So what's that going to be? That's 80, 99, 101, negative 101. So the point we care about is negative 3, negative 101. So the slope we care about is, I'm just going to update this one here so I can save myself a little bit of work. Cool. Is the y2 minus the y1, that's really plus 101, over x2 minus x1. So it's x minus negative 3, which is x plus 3. And, oh, we're approaching negative 3. Okay. And let me just double check this negative 3. That's negative 27 times 2 is negative 54. 9 times 4 is 36. Negative 3 and 3 is negative 9 and 2, right? This makes 80. And 10 is 90, 99, 101. Okay. So minus 2 plus 101 back here is actually going to turn that into a plus 99. And if I plug negative 3 into that, I'm going to get 0, which means I can put a negative 3 here, a 2, a negative 4, a 3, and a 99. And all I'm doing is factoring this equation. So we bring down the 2, negative 6, negative 10, 30. This is 33 times negative 3 is negative 99, and that adds up to 0 like we expected. So that means, get out of here, you. That numerator factors into x plus 3 times 2x squared minus 10x plus 33 all over x plus 3.
Look at this.
Hang on, big guy, and I want to know what's happening here. Okay, so the x plus 3's cancel.
Oh, look at something.
And you plug in negative 3 now, because now we can plug it in because we canceled out the x plus 3's that had to happen. We're going to get 9 times 2 is 18. 10 times negative 3 is negative 30, so it's actually plus 30 plus 33. So that's 48 plus 33, and that's 78 plus 3 is 81, right? Sounds good. And that's the slope of that cubic. And you can see it's really steep. A slope of 81 is very, very, very steep. That means if you go over 1, you go up 81, which I have no scale on here, but I have to go super high up. All right. So, number 5. Young boys, keep working. You're doing a good job. We're almost done. Ooh, okay. So here we got a fraction one. So at 1, the y value would be 1 comma, you put a 1 in there, you get what, a sixth? Cool. So our slope is going to be the y value that's varying, which is just the function, right? Because you plug any number into that, minus the y value at the point we care about over x minus the x value we care about. You want to know what's happening to that as we approach 1. Well, here now, this is kind of a pain in the butt. We have to multiply to get rid of these fractions. So 2x plus 4 and a 6. We can actually reduce that down a little if we had to, but don't worry about that. It'll work out in the end. Okay, like the common denominator is really x plus 2x plus 4 and a 3, but it doesn't matter. This will work if we just multiply by both things. When you multiply these to here, the 2x plus 4s are going to cancel. So it's going to leave you with a 6 minus. When you multiply these to here, the 6's cancel. So it's going to leave you with 2x plus 4. Super common mistake is to forget those parentheses. So don't forget those. Then we have an x minus 1. We're multiplying in this 2x plus 4 and this 6. I'm just going to let those lie. So this part right here is going to become negative 2x, right? Minus 4, but plus 6. So that's actually a plus 2 there if you simplify that down. Okay, and if you take a negative 2 out of that, you're actually going to get negative 2 times x minus 1 over x minus 1. And we knew the x minus 1s had to happen because they have to cancel. Boom, times 6. And the x minus 1s cancel out. And now I can just drop my 1 in there because, again, we're seeing what the slope approaches at 1. There was a hole in the original slope equation, but once we cancel that out, we find out where the hole is basically what's happening. So you can also see here that a 2 can cancel out, and that's because we didn't reduce it initially, but that doesn't really matter. We can just do it at the end. That's negative 2 over. If you put a 1 into here, you get 6 times 6. So it's 36, which we're going to say is negative 1/18th, which makes sense too because look, this is a 2x. So our function is 1 over 2x plus 4, right? That has an asymptote at negative 2, and it looks like this. So if you find the slope of that thing at 1, So this is 1. The slope of that's really, really low because it's getting flat over there. That's why it's a 1/18th. It's negative because it's going downward if you see that in the picture. Okay, Google, stop. E, you're done. Okay, Google, set a timer for 10 minutes.
I'm gonna stop this.
10 minutes.
All right.
Starting now.
It's a good time of day.
Luke, I'm done.
Elliot's done.
I have actually 9 minutes.
You have 10 minutes, boy. Keep going.
I have 9 minutes.
You don't tell me. I tell you.
When I started, there was a timer that was on 20 that I had on my computer.
Well, now you're wasting time. So I'm adding an extra minute. Okay. Never back down, kids. Okay. At -2, the point we care about is -2, comma. If you put a -2 into there, you get -4 plus 4, which is 1/0, which is undefined. So what that means is there's no point there. Cool? That's not a real y value. And that's happening because 1/2x plus 4 has an asymptote at -2. It looks like this graph right here. So if I ask you to find the slope at -2, if there's no point there, we can't find a slope. So you just say, hey, there is no slope there because there's no point there. Cool? And we got a fancy word for that. I'll tell you later on. Let's call it not differentiable. We'll talk about that later on. All right. And for the bonus, which I know you all want to try, got that radical. It's not really too bad. The point is going to be 3, comma 2, because you put 3 into there, you get √4. And we're going to have y1 minus y2 over x minus x. And we want to know, yo, what's happening as we approach 3? So we talked about this too. If you got radicals, you want to get rid of them with the conjugates. So the conjugate of √x plus 1 minus 2 is √x plus 1 plus 2. So the sign, plus 2. The sign inside the radical, the x plus 1, that doesn't change because that's like all one big thing combined together. The sign that matters is the difference between them right there. So that's what changes to get that conjugate. And we talked about conjugates. When you multiply them, it squares the first thing. So √x plus 1 squared, when you multiply it together, you're just going to get x plus 1. Cool? The middle terms cancel. Like if you fold it out, the middle terms are going to cancel. Then you're going to get -2 times 2, which is -4. So it squares both of them. On the bottom, I'm just going to leave it alone. We're not going to multiply that out because remember, our goal was to cancel out the x minus 3. And look at this. X plus 1 minus 4 happens to be x, hey, get out of here, minus 3. And they cancel out. So there's a 1 on top. So our slope boils all the way down to this thing. Okay, and if you plug a 3 in there, it's going to tell us where it's going. And that will be 1 over √3 plus 1, that's a 4. So 1 over 2 plus 2 is 1/4. Okay, and lastly at 8, our point's going to be 8, comma 3, right? If you plug an 8 in there, you're going to get 3 as your y value. So this is going to become √x plus 1, so we're headed to 8. I'm just changing all these, approaching 8. This is going to be a minus a 3, and this is going to be minus an 8, which means we're going to be multiplying by plus 8. Okay. Nope, this is going to be plus a 3. Sorry, I'm getting ahead of myself. Because we're doing the conjugate of the numerator, because we got to unlock that radical. When we multiply the conjugates, we get the first thing squared, x plus 1, minus the second thing squared, 9. But x plus 1 minus 9 is x minus 8. They're going to cancel, right? Goodbye. Leaving a 1 up in the numerator there. And if you drop an 8 into there, you're going to get 1 over √9, which is 3 plus 3. 1/6. There you go.